You wish to test the following claim at a significance level alpha is 0.10 or 10%. The null hypothesis states that the proportion is 29%, and the alternative hypothesis states that the proportion is different from 29%. You obtain a sample size of 244 in which there are 60 successful observations. For this test, you should not use the continuity correlation, and you should use the normal distribution as an approximation for the binomial distribution. What is the critical value and what is the test statistic? And then we need to answer the rest of the questions. So this is hypothesis testing for proportions. I'm going to pull the Master Excel workbook, and the null proportion is equal to 29%. So I'm going to change the null proportion to 0.29, and this is a two-tailed test, and then the sample size is going to be 244 and x is equal to 60. 244 and x is equal to 60. We don't have p hat, so I'm going to remove p hat here. We don't need it. The significance level is 10%, I believe. It is 10%. So here is 10% for significance level alpha, 0.10, and that's all we need to change here. So now we need to find the test statistic, the positive and, the critical value, I believe. The critical value and the test statistic, both of them. So here I'm going to, since I copied the test statistic, I'm going to head to the second box and put it in the second box. And then we need the positive and negative critical value. So I'm just going to copy the positive one because this is a two-tailed test. So clearly there are two critical values. And then I am going to just submit this to make sure my answers are correct. Now, how do I know if the test statistic is in the critical region or not? You can do it in two ways. One way is to look at the graph. As you can see here, the test statistic is negative 1.5. Negative 1.5 is approximately here, which is, to be honest, not very clear from the picture, but you can basically compare that to the critical value. The critical value is negative 1.6, which is basically smaller than negative 1.5, which means the test statistic is not inside of the critical region. So actually from the picture, it's kind of telling me the same thing, but it's not very, very obvious. Another way to tell is when the decision is failing to reject the null hypothesis. That means the test statistic is outside of the critical region or the rejection region. So that is another way to tell. Okay, so we're going to say it is not in the critical region, which means we're going to fail to reject the null hypothesis. If we fail to reject the null hypothesis, that means we do not have sufficient evidence to support our claim. So let's see what are these conclusions that we have. The first conclusion, there is sufficient evidence to warrant the rejection. There are two mistakes here. First of all, we don't have sufficient evidence. Second of all, we do not use the language of like warranting the rejection of the claim. We never reject or accept the claim. We only reject the null hypothesis or fail to reject the null hypothesis. That is the language that you should focus on. There isn't such a language that deals with the rejection or the acceptance of the claim. There isn't sufficient evidence to warrant the rejection of the claim. Again, we do not reject the claim or accept the claim. So the second conclusion is not accurate. The sample data supports the claim that the proportion is not equal to. We don't have evidence, so the sample data does not support. There isn't sufficient evidence sample to support the claim that the population proportion is not equal to 0.29. That's exactly what we need to click. We don't have sufficient evidence to support the claim, and then we state the claim, so that is the correct answer.